Hello, I'm Yuji Chang. Today we are going to walk through a complex numbers question that brings together algebra, geometry, roots of unity, and rotations. Let's begin. It's a given that phi equal to a plus bi to the cube. And in part A, it asks about the real part of phi and imaginary part of phi. So we need to expand phi. To expand it, I'll apply binomial expansion, now which is a to the cube bi power of 0 plus 3 a squared bi plus 3 a bi to the power of 2 plus a to the power of 0 bi to the power of cube, which gives us a cube plus 3a squared bi plus 3a minus 3a bi minus b to the cube I. And this is real, so you can write it as a to the power of 3 minus 3a b is squared plus 3a squared b minus so you can write it as real part of psi equal to a cubed minus 3ab squared, and imaginary part of psi equal to 3a squared b minus b to the power 3. Okay, that's the part of A, and part B, hence otherwise show that a plus root 3i to the power of 3 equals negative a. In part B, show that the 1 plus root 3 I to the power of 3 equal to negative a. So we can apply a equal to, let a equal to 1 and b equal to root 3, then substitute in that equation we given, we found out, then which is 1 to the power of 3 minus 3 times 1 times root 3 to the square, and plus 3 1 square root 3 plus root 3 minus 3 root cube I. If we simplify it, that's negative a, and here gives 0i. That's so that's what's proven. Part C, the root of z to the power of 3 equal to negative a. And you need to find u equal to 1 plus root 3i is given, and v is in real number. We need to find v and w. But if 1 plus root 3i is a root, then its conjugate is root as well. So 1 minus root 3i is a root. But v is a real number, so w has to be 1 minus root 3i. If you multiply 1 plus root 3i, 1 minus root 3i gives us 1 plus 3, which is 4. Then turn out to be negative a, v has to be negative 2. So that's the answer. Move on to D. Find out area of the triangle UVW. Okay, if you draw the Argand diagram, it's a real, that's imaginary part. Then 1 plus root 3i here, and 1 minus root 3i here, and negative 2 would be here. So we want, that's u. So we want that triangle, area of that triangle. The side length is 2 root 3, and height here is 1, so the height is 3. The area of UVW equal to half times 2 root 3 times 3, which is equal to 3 root 3. Okay, for E, we need to find out U dash, V dash, and W dash. And giving your answer in form of R times E to the I theta. So, first of all, we need to find out U, V, W of the polar form. Then Z cube is negative A. And you can rewrite as A times E to the pi plus 2k pi I Z cube. So Z is 2 times e to the pi plus 2k pi over 3I for k equal to 0, 1, 2. So when k equal to 0, Z is 2 times e to the power of 3I. K equal to 1, Z equal to 2 times e to the 3 pi over 3I, which is 2 e to the pi I. K equal to 2, Z equal to, let's call it Z 1, 2, 3, Z 1, 2, 2 times e to the 5 pi over 3I, which is negative pi over 3I. So that's when k equal to 0, that's the U, that's V, that's W. And to find out U dash is U times e to the pi over 4I, then which is 2 times e to the pi over 3I times e to the pi over 4I, which is 2. If you add together, you get 7 pi over 12I. And V dash would be 3 times e to the pi over 4I, which is 2 times e to the pi I times e to the pi over 4I to the 5 pi over 4I, which is negative 3 pi over 4I. And W dash equal to W times e to the pi over 4I, which is equal to 2 times e to the negative pi over 3I e to the pi over 4I, which is equal to 2 times e to the negative pi over 12I. Okay, in F, U dash and V dash and W dash are all roots of Z cube equals C plus DI. So if you take one of the roots and multiply by 3 times, then we get C plus DI. So I'll take U dash. Then U dash was 2 times e to the 7 pi over 12I. We take cube. And U dash equal to A times e to the 7 pi over 4I. Can be write it as A times e to the negative pi over 4I. You can rewrite it as cos minus pi over 4 plus I sine minus pi over 4I. And since cos negative pi over 4 is 1 over root 2, so that's 1 over root 2. And sine negative pi over 4 is negative 1 over root 2, so negative 1 over root 2 2I, which is 8 over root 2 minus 8 over root 2I. If we rationalize it, then we get 4 root 2 minus 4 root 2I. Therefore, C equal to 4 root 2, D equal to negative 4 root 2. So in G, all these 6 roots are the solutions of Z to the power of n equal to alpha. And we want to find n. So to find out n, we only just take the argument of the old root. Then we get pi over 4, no, pi over 3. And pi, negative pi over 3, 7 pi over 12, and negative 3 pi over 4, and negative pi over 12. If we rewrite it as in our ascending order, then you get negative 3 pi over 4, negative pi over 3, negative pi over 12, pi. If you find the common denominator, which is 12, so you can rewrite as 12, negative 9 pi, and negative 4 pi over 12, and negative pi over 12, and 4 pi over 12, 7 pi over 12, and 12 pi over 12. So difference between these angles, it's 5 pi over 12, that's 3 pi over 12, that's 5 pi over 12, and that's 3 pi over 12, and that's 5 pi over 12. Okay, that's still for the 어쨌든 뭐야? 다시 할게요. 힘들다.
이제 마무리만 하시면 되세요.
네, 끝났어요.
마무리 말만 해주세요.
마무리 얼마 할게요. Okay, let's bring us to the end of the problem. And thanks for listening. And I hope that you feel much clearer about the complex numbers. Thank you.